The big question for this segment is, what are some examples of the breakdown of complex systems in the biosphere? The Earth's sixth mass extinction event is underway. Human modification of the environment is producing extinction rates 1,000 to 10,000 times the natural background rate. In the last 500 million years, there have been 5 other times when life on Earth was nearly wiped out. By climate change, an intense ice age, volcanoes, or the space rock that smashed into the Gulf of Mexico, obliterating the dinosaurs. The sixth mass extinction is human-caused. There are 4 main causes of the present extinction event: habitat destruction and degradation, introduction of exotic pest species, pollution, and overexploitation. Habitat loss is a threat to 85% of the species listed by the International Union for the Conservation of Nature as at risk of extinction. Food production, which often involves clearing of land for agriculture, is a major agent of deforestation. Urbanisation and mining also cause habitat destruction on the land, and in the sea, trawling and dredging are major causes of habitat loss. Around half of the world's forests have already disappeared, and clearing continues at 10 times the rate of regrowth. This is of particular concern given that it has been estimated that tropical forests contain at least half of the species on Earth. Globalisation has resulted in unprecedented rates of species translocations across the globe. Some of these species translocations are deliberate, for example for agriculture or ornamental purposes. Others are unintended outcomes of species hitchhiking, for example in ballast water or on the hulls of ships. Non-native species can have large negative impacts on biodiversity where they are predators, competitors, or parasites of native species. Of threatened species in the United States, introduced species alone or in combination with other factors have contributed to the declining status of at least 50% of these threatened species. Pollutants come from many sources, but anthropogenic greenhouse gas emissions are one of the most significant. In changing the Earth's climate system, they affect all ecosystems on Earth. Among the physical changes arising from greenhouse gas emissions are warming, sea level rise, ocean acidification, altered rainfall patterns, and in some parts of the world, an increased frequency and intensity of storms. Organisms that cannot tolerate this climatic change must either adapt or migrate to avoid extinction. It is predicted that 1/4 of all species will become extinct by 2050 if warming continues at its present rate. The final leading cause of extinction is overexploitation. Many species are harvested for food, fur, fuel, or some other valued resource. Where harvest exceeds the rate of natural replacement, populations decline. Fisheries are particularly vulnerable to overexploitation as they span multiple jurisdictions. According to the United Nations Food and Agriculture Organization, over 25% of the world's fish stocks are either overexploited or depleted, and over 50% are fully exploited. The order in which species are going extinct is non-random and is determined by biology and human worth. Species such as gorillas, that produce few offspring and take a long time to reach sexual maturity, are particularly prone to extinction because their populations recover slowly following decline. By contrast, species such as mussels, that release millions of sperm and eggs into the water in broadcast spawning events, can rapidly repopulate areas following removal of environmental stressors. Species that can disperse broadly, for example through flight, land-based migrations, or water or windborne reproductive propagules, may be able to migrate from suboptimal to optimal habitat, or shift poleward to cope with a warming climate. Island-dwelling species are particularly prone to extinction due to their geographic isolation. Species that have narrow environmental tolerances or exist in just a few places on Earth are most susceptible to environmental change. For example, a cyclone, flood or fire may wipe out an entire species if its distribution is wholly within the affected area. By contrast, those species whose distributions extend beyond the affected area will persist. Finally, species that provide a resource to humans are most likely to be driven to extinction through overexploitation. The net effect is that particular functional groups are being removed from ecosystems. The problem with extinctions is that the more species we lose from ecological communities, the more sensitive they become to environmental change. Interactions among species can enable them to persist in environments that might otherwise be unfavourable. For example, canopy-forming seaweeds on rocky shorelines provide shading and trap moisture when the tide goes out, enabling other species to persist higher on shorelines than their own environmental tolerances would predict. Similarly, species such as trees or corals that increase resource availability or provide complex structures may enable species to coexist that may otherwise compete for food or territories. Loss of these facilitative species will have large cascading negative impacts on the species which depend on them. Similarly, loss of top predators can place species in danger. The near extinction of sea otters in Monterey Bay due to overhunting for fur in the 1800s had catastrophic impacts on kelp forests and their dependent species. In Pacific kelp forests, sea otters feed on urchins and urchins feed on kelp. Culling of otters allowed urchins to proliferate, and the urchins in turn decimated kelp, transforming kelp forests into barrens. The loss of species is of concern, both in terms of their intrinsic value and the services they provide to humans. Biodiversity provides humans with food, with water and fuel, maintains clean air and clean water, cycles nutrients, and provides recreational and aesthetic benefits. The functions of ecosystems that underpin these services are generally greatest where biodiversity is species rich. Hence, as species are lost, so too will be the services on which we depend. Initially, species loss may not result in noticeable loss of function due to redundancy, much like rivets on a plane. However, once too many rivets are lost, the plane will crash. Curbing the loss of species will require a shift in human thinking, from considering us as distinct from to at one with nature. Education is key in sharing the plight of species and the opportunities for and benefits from human behavioural change. Practical solutions will require a combination of conservation, restoration, rewilding, engineering, and design. Although the devastating effects of our species on the planet are clear, if we act now, we may be able to prevent the plane from crashing.